Welcome. So in this part of our video, we are going to be completing the calculations for NPV, discounted payback, IRR, and ROI using the example that was contained within our lecture. I'm going to break it up into a series of 4 videos, one video for each calculation. And in this one, we're going to focus in on net present value. So a couple of things first and foremost to make mention of. The way that I've set up my spreadsheet here is by no means the way that you need to set up your particular spreadsheet. There are multiple ways of using Excel to do calculations, and you're more than welcome to do so in a way that is easier for yourself. As long as the calculations are done in a systematic way, I think the benefits of learning how to approach NPV are going to be there. What I've done is I've set up a table with all of my values and my calculations on the left-hand side, but I've also created on the right-hand side a cash flow diagram. And I use the cash flow diagram because I believe it's just a easier way of visually representing the problem on hand. It doesn't have to be to scale. It just shows very quickly what the outflows and the inflows are. Now, in some cases, this particular example shows an outflow only for the current year and then inflows, revenues, for all subsequent years. That doesn't necessarily mean that that's the way our project can be estimated or evaluated. There might be outflows in year 0, but there also might be outflows for year 1, year 2, year 3, and so on. At the same time, we have inflows. Those outflows could be things associated with maintenance costs. It could be software licensing costs that are required to support the product. And then we have revenues. And so we have to make sure that when we're calculating NPV, that it is the net cash flow for each particular year, meaning we have to look at the inputs and the outputs and look at the sum total of those two variables. Okay? And the cash flow diagram will allow me to see that I may have in year 1 some sort of expenditure, year 2 some sort of expenditure, and so on. And so that when I go to do my calculations, particularly in column B, I make sure that I have the net cash flow for that particular year, i.e., again, I take into account the outflow and the inflow. I'm looking at the sum total of both. So what I have here is I have my year 0 through 5. I've got each of the cash flows, the net cash flows, in this case $1,000 as an expenditure in year 0. And these are costs that could have been associated with developing the product, or resources, material. Think of them as project costs. And then in year 1 through year 5, as part of our business case, we've projected that this particular widget will have net positive cash flows of $200 for year 1, $400 for year 2, $500 for year 3, and so on through year 5 of $600. Now again, to see and calculate NPV, I have to take those future values for each year and convert them into present value dollars. And then, based on the sum total, I can calculate the net present value, right? And that's an important term. It's net present value. So it's the sum total of all present values from year 0 through year 5. The other column, and the way that I approach this particular evaluation of this particular calculation, is I put in sort of an interim column, and I called it the discount multiplier. And really what this discount multiplier is, it's just the part of the present value formula that multiplies the future value and converts it into the present value. So really it's the present value formula without the future value component. It is 1 over 1 plus I, which is the discount rate, to the power of n, which is the year in which that cash flow occurs. And so if you do the math, and again, the way that you set it up, you can look over here at the way that I've created a formula just so I can do the calculation fairly quickly. I told Excel where to find the discount rate. In this case, remember, we're using 8.5%, so I have 0.85 here. I also told it where to find that particular value of N. In this case, for year one, it's looking in column A, cell 5. And this then allows me to very quickly copy and paste the formula all the way from C through to C1 C4 through C9. Okay, and again, how you choose to do this, if you want to do it on a calculator and plug in the number, I just find if I automate the spreadsheet, it's going to help me a lot more later on. So if you do the math, right, for year one, the discount multiplier taking into account a discount rate of 8.5%, or in this case 0.085, and you have to convert it to a decimal, works out to 0.92 and some odd numbers. Again, you can round this if you would like. If it's a little bit easier, you don't have to keep 7 or 8 digits here. You can just round to the nearest, probably nearest 100th or 1000th is probably good enough. 0.84 for year 2, 0.849, so 0.85 approximately, 0.78, 0.72, and 0.66. And now what I've done is simply multiplied that discount multiplier, which again is that portion of the present value formula without the future value, which reside in column B. And I simply multiplied those two out to get the present value of the future value. So in this case, obviously something in year 0, we have a present value of 1,000. That is current time. And so that present value is still 1,000, right? And anything raised to the power of 0 in the formula down here to the power of n, mathematically speaking, would yield a 1. So that makes sense. $1,000 today are worth $1,000 today. $200, which is something that we forecasted for year 1, its present value, so $200 is the future value, but given the fact that we have a discount rate of 0.085 and we have this flow happening in year 1, when we do the math, it works out to $184 and some odd cents. That's the present value of the future $200 value that occurs in year 1. For the value of $400, which occurs in year 2, its present value after doing all of the math is $339. Present value of $500, which occurs in year 3, is $391. Present value of $550, which occurs in year 4, is $396 and some odd cents. And $600, which happens in year 5, its present value is about $399, or roughly about $400. And so now all we need to do is to calculate net present value. Again, keep in mind what the formula is saying. Net means sum. It is the sum of all of the present values. In this case, we had 5 future values converted to present value, including the current present value of $1,000, the expenditure, the costs of this particular project. And when we add them together, we will see that that brings us to a sum total of $711.46. And so the NPV of this project 1, it is positive. So if we have nothing else to compare it to, at the very least we know it's a positive NPV, in which case it makes it a favorable project. Okay? If the NPV was negative, the advice would be not to move forward with this particular opportunity. Now the good thing about Excel is that you can also use Excel functions to do the calculation for you. So rather than having to do the discount multiplier and the discounted cash flows and doing this sum total, you can actually use the NPV value or NPV function to calculate for you, as you can see up here. Okay, so very quickly, what that will do is, in the way that you write it, there's a certain form that you have to follow, but really, and let me just find a little spot in here somewhere and just do it over here. So what you can do is you can use the NPV function, and remember, it's asking you for the rate first. So make sure you put in the rate. Then it's asking you for the values. Now for the values, you take all the values except for the current value, because that's already in present, and we don't want to include that in the calculation. The way that the function works is we don't include that. But what we do include are all of the cash flows in the subsequent years. Okay, and I'll just do that for now, and you'll come out to $1,711. But what this doesn't do is it doesn't take into account the $1,000 expenditure that we had put in. So to this, we have to add back in the $1,000, in which case it's a subtraction. We'll just accept this, and Excel will calculate $711.46, which is what was shown here, and which was our value that we calculated on the right-hand side, going through step-by-step calculation of which year. Now, the advice I give you is, in an exam situation, by all means, time is of the essence. I strongly recommend that you use a spreadsheet like this, maybe pre-populate things ahead of time, and then use it to do calculations fairly quickly, because I'm not going to be looking for you to show me your rough work. It's really multiple choice, and you're looking for the correct answer, and then you want to move on. So this is a way that you might be able to save some time and sort of prepare. And in real life, we really don't do the calculation step by step. Most organizations have some sort of workbooks already completed where project managers populate these numbers, and a lot of the calculations are done for you in the back end, and the values are shown to you. So you need to kind of understand where this is coming from, what net present value means, why net present value of positive dollars is important, and why when you're comparing two projects and you can only select one, and you're only looking at net present value as a single factor, you want to select the project with the highest NPV. Those are things that you need to understand, but the calculations, like I said, usually done in the back end, and most organizations have sort of pre-populated workbooks, and you can just leverage those. For your assignment though, I do want to see the work done. And so I'm okay with you validating your answers using the Excel function. I'm also looking for either a setup, like a table like this, that shows the step-by-step calculation, or if you don't want to use Excel, if you're not comfortable with it, and you just, even though it's going to take a little bit longer, but you just want to do the math on a piece of paper, and you want to take a scan of that paper that shows all your work, all the interim steps, and create a PDF document, or JPEG, or some other sort of means of demonstrating that you've done the work. That would be the expectation, and you can upload that with your assignment so that I can see that the work is done. Your choice, but this is just a quick example of how you can use Excel and do the math as well for an NPV calculation.